All right, fifth grade, this is your first week of remote learning. We're going to be on page 98 and 99 today. We did some of this on Friday, but let's review what we did on Friday first. So we first learned what a prime and composite number are. Prime numbers are numbers that I can only multiply by that number and 1 to get that number. For example, 7. I can only do 1 times 7 to get to 7. Another example would be 13. I can only do 1 times 13 to get to 13. An example of a composite number would be 15. I can do 1 times 15, or I can do 3 times 5. 16. I can do 8 times 2, I could do 4 times 4, I could do 16 times 1. Those numbers are composite. A prime number is when you can only multiply by that number and itself. Then we talked about prime factorization, so let's do one of those. And then I'm going to walk you through some classwork for today. So if you weren't here at school Friday and you didn't watch last week's YouTube video or the one that's on last week's lesson, you need to go back and watch that. So let's do one like 16. If they give us a number 16, I need to figure out what two numbers multiply to get 16. 4 times 4 comes to mind first. Doesn't matter, you could do 8 times 2. You cannot do 16 times 1 because you're just going to keep repeating. My goal here is to get all prime numbers at the end. So I have 4 and 4. Those are not prime, they're composite. So I break them down again to 2 times 2. 2 is a prime number, so I can circle it and be done. Now I'm going to come back over here and do the same thing. So now my prime factorization would be 2 times 2 times 2 times 2. Or, to make it more simple and to make it better, I could do 2 to the 4th power. The 4th power is because I have 4 2's. It only works for the ones that have the same number. So let's do another one. Let's do 32 next. This will work with any composite number. You're not going to have a prime factorization of a prime number. All right, so 32. I do 8 times 4. And I'm going to break down 8 to 4 times 2. 2 is prime, so I can circle that number and be done. 4 is composite, so I need to break that down to 2 times 2. And then this 4, I need to break down to 2 times 2. Now I have 2 to the 5th power, or 2 times 2 times 2 times 2 times 2. It just makes it a whole lot simpler if you go ahead and put 2 to the 5th power. And again, that 5 right here is because I have 1, 2, 3, 4, 5 2's. Okay, let's do another one. You're not always going to have just 2's as your answer. You could have any prime number. You could have 3, 7, any of those. So don't get confused and think it can only be that number. Let's do 18. Okay, if I want to break down 18, I'm going to do 9 times 2. 2 is prime. I'm going to go ahead and circle it. And to get 9, I do 3 times 3. Can't do anything else with 3. If I broke down 3, it would be 3 times 1 over and over and over again, which is pointless. So it's just 3. So my prime factorization would be 2 times 3 times 3, or 2 times 3 squared. And that 2 right here in the exponents is because I have 1, 2 3's. Okay, so this is going to be your best answer. Okay, so let's look at what you're going to do today. These are actually pretty simple once you get the hang of it, but you do have to pay attention to what you're doing. The first one you're going to do today is number 12, so let's do it together. It's going to ask you to make a factor tree. So you're going to make a factor tree for 42. So the first thing you think of is, how do I get to 42? Well, I multiply 6 times 7. 7 is already prime, so I'm going to circle it. Then I need to get to 6. So I get to 6 by doing 3 times 2. 3 and 2 are already prime. So my prime factorization is 2 times 3 times 7. Okay, so you're breaking it down until you cannot break it down any further, until you get to a prime number. So that's number 12. We did that together. You're going to do 12 through 16. Then you're going to do 27 through 32, which is going to be pretty much the exact same thing you just did. So give me just a second. On 12 through 16, they don't ask for the prime factorization, but you can go ahead and do it. For number 27, there is this right here, they do ask for prime factorization. So they're going to give you 78. You're going to have to think of what two things give you 78. So let me see right here. Ms. Clark is going to use a calculator because she doesn't want to think of what makes 78. All right, so just a second. They gave us 13 and 6 in the book. They don't give that to you in the book, but you could do 78 ends in an even number. So divided by 2 would be 39 and 2. You could do those two numbers. It's easier to do two numbers that are smaller versus a number that's too big, because then you're going to have to do it more times. So 13 times 6. 13 is prime. We can circle it. 6 is not prime, it's composite. So I need to go down, break it down into 3 times 2. So your answer would be 2 times 3 times 13. And notice that there is no exponents there because I only have 1, 2, and 1, 3, and 1, 13. So 2 times 3 times 13 is your final answer for 27. You'll do that for 17 through 32. I'm sorry, 27 to 32. So this is your work for Tuesday. Your homework is going to be workbook 93, which you'll see on Shobi. And I will see you guys back for Wednesday. All right, Wednesday video. Today you're going to do a little quiz. It is on Shobi. It is just basic factor trees. It's honestly easier than what you've already done. But let's do a couple just to practice. Let's do one like 45. To get to 45, I would do 9 times 5. 5 is already prime, so I'm going to circle it. And to get to 9, I would do 3 times 3, and those are prime. So prime factorization would be 3 squared times 5. I'm pretty sure that on your quiz, it's going to just ask you to do something like this. It doesn't give you the option for the exponents, but if it does give you the option, you go ahead and do it. But I'm pretty sure it's going to be like this. Okay, so let's do another one. Let's do 350. Let me show you if you get a big one like this. Okay, 350. You know that if it has a 0 at the end, it can be divided by 10. So I'm going to do 10 and 35. That breaks it down into numbers that are much easier to deal with. So for 10, I'm going to do 5 times 2 to get to 10. Both of those are prime, so let's circle them. And then for 35, it's 5 times 7. Both of those are prime. So 2 times 5 squared times 7, or 2 times 5 times 5 times 7. Okay, so go ahead and work on your quiz for today. Tomorrow we're going to do something a little bit different, but it does require you to know this before we can move on. So go do your quiz. If you have any questions, let me know. All right, Thursday. We're going to be on page 100 today. This is something that's huge for you to know. this is going to be something you have to know for a fraction, so you do need to make sure you pay plenty of attention to this and you do understand it. Look at page 100 with me. Piper is organizing musical instruments in a closet. She wants each shelf to have the same set of instruments. There are 15 recorders and 27 harmonicas. What is the greatest number of shelves Piper can use to store the instruments? The greatest common factor of two or more numbers is the greatest number that is a factor of all the numbers. It's a bit wordy, so let's look. First off, it's called GCF, greatest common factor. So here are your steps to find the GCF. Number one, list all the factors of each number. And step two, select the greatest factor they have in common. So, seems like a simple steps, right? It's really going to be easy once we do it. I think this is easier than the factor trees. I'm going to clear this out. If you are still copying it, of course, just pause it and then come back. All right, so let's go with an example. So they might give you GCF of 15 and 27. It's always going to be two numbers that you're going to be looking at. So we put 15 here, 27 here. Then we think of every combination of multiplication we can do to get to 15. So first I can do 1 times 15. It's kind of like a little rainbow. I can't multiply anything by 2, but I can do 3 and 5. It's easier if you space them out like that and do 1 and 15 and fill in the middle. I just go in my head 1, 2, 3, 4. There's nothing to multiply by. 5 we already have on here. There's nothing times 6, nothing times 7, nothing times 8, 9, 10, 11, 12, 13, or 14. These are the pretty easy ones that you can know in your head. This is where your multiplication facts come in. All these are multiplication facts. 1 times 15 and 3 times 5. So for 27, I could do 1 times 27. I can't do anything with 2. I could do 3 times 9. Can't do anything with 4. 5 times something doesn't equal 27. 6 times something, 8 times something, 9 times something. Well, 9 is already here. That's as high as I can go. I'm gonna erase this and make it a little bit closer. So 1, 3, 9, and 27 are all the factors of 27. So then I just pick the biggest one they both have in common. They're both going to have 1 in common every time. But look further. They both have this 3. So the GCF equals 3. Okay, so each shelf would have, she would have 3 shelves, 5 recorders on the shelf, and 9 harmonicas. So let's do, just a second. Okay, I'm gonna clear this out. Let's do the GCF of 36 and 42. Okay, it's gonna give you something just like that. So we're gonna put 36, 42. I know, that I can do 1 times 36. I can do 2 times 18. I can do 6 times 6. I don't need to put 6 twice though. I can just leave it for the 1. 7 doesn't work. 8 times something doesn't equal 36. Actually, it does with 4. So hold on, let me rewrite that because we didn't put 4. 4 and 9. 6. 7 doesn't work. 8 times something doesn't give 36. We already have 9. So that's about as far as we can go. So let's do 42. I can do 1 times 42, 2 times 24. Let's see. Remember, I can do 4 plus 2 equals 6. So 42 is divisible by 3. So let's go off to the side and figure it out. So 3 and 14. 42 divided by 4. Nope, that's not going to work. Can't be divided by 5. 6 times 7 equals 42. 8 times something doesn't equal 42. 9 times something doesn't equal 42. We're about as high as we can go here. So what you're thinking is what two numbers make 42, which pairs. Now that we've gotten them all listed, we go through and see which is the highest. They both have 1. They both have 2. So let's circle all the common ones. They don't both have 4. They both have 6. 9, 10, so that seems to be it. So our GCF is 6. So we list out all our factors, pick the biggest one. All right, let's do one more. Let's do 14 and 20. So to get to 14, I can do 1 times 14 or 2 times 7. To get to 20, I could do 1 times 20, 2 times 10, or 4 times 5. Okay, so I have the 1s in common, the 2s in common, and that's it. So my GCF is 2. Okay, so that's what you're going to be doing today. You're going to be doing 1 through 3. That's a little chart in your book, okay? Let me know if you have any questions. All right, guys, more GCF today. You're going to be doing 4 through 12. So look in your book at those, page 101. This is what you're going to be doing today. So let's do a practice one. Let's do 24 and 36. I'm going to put 24, 36. I can do 1 times 24. 2 times 12. I'm going to move the 24 down. And I can do 3 times 8 and 4 times 6. So my factors for 24 are 1, 2, 3, 4, 6, 8, 12, 24. 36, I can do 1 times 36. 2 times 18. Let's see, for 30. 3 times 12. And 6 times 6. So those are all the factors for 36. 1, 2, 3, 6, 12, 18, 36. So let's circle in red our common ones. 6, 12. So our GCF for this is 12. That's all you're going to do today, okay? So go ahead and get started on this. If you have any questions, let me know.